Okay. Hello,
everybody. Welcome. Here we go. Thank you all for coming. Appreciate everybody here. This is going to be an exciting couple of hours. We have some of the best projects in Web3. My name is Tom Trowbridge. I'm a co-founder of Fluence Labs. You're going to be hearing from my fellow co-founder, Evgeny. If you don't know much about Fluence, you'll find out a lot more about it. But we are a peer-to-peer compute platform. So let's save that for the moment. But just a quick couple of housekeeping items. First, feel free to get a drink, some snacks. They're right there. That's to begin with. We're going to have 2 talks and then a break, and then a panel where all the projects are going to be on, led by moderated by Lasse Clausen from 1KX, one of the premier investors in the space. And then we're going to have a couple more discussions, and then we're done. And there will be an after party hosted by Livepeer, which will follow not in this space, which we have to be out of by, I think, 6 o'clock. So we'll be headed somewhere else. I'll give you those details a little bit closer to it. But right now, I want to turn it over to Sam Williams, the founder of Arweave. And if you don't know what Arweave is, you're in the wrong room. So with that, I'll give it to Sam.
Okay, thank you. You good with this?
Oh, yeah.
Is this what? Okay, great. Well, actually, I would say that you might be in the right room. I'm about to tell you. But yeah, this is a little bit about Arweave, which is a permanent data storage system. And the journey we've been on trying to build a, yeah, got it, thank you. The journey we've been on trying to build a blockchain-based application, which is really nothing to do with finance, and trying to get that adopted and pushed out into the world. So broadly speaking, Arweave is a blockchain scale to store arbitrary amounts of data inside. Imagine that you can put. We can't hear you at all. You can't hear me at all. Let's try this one.
Right close.
Right close. Yeah. Oh yeah. Yeah, okay, that's better. Okay, so yes, Arweave is a blockchain that's scaled to store arbitrary amounts of data inside. You can essentially think of this if you're aware of how it works in Bitcoin or Ethereum, as you can just add a memo field, which is essentially arbitrary inside. So it can be up to 2 to the power 256 bytes in a single transaction stored on chain. And then we, of course, shard that data storage between many different storage providers in the network, and critically, we provide an endowment structure to sustainably back the storage of that information over time. And this is really important because, of course, if you have on-chain storage that allows your ledger to grow to basically massive sizes, but like, how are you going to make sure that in the future, say 100 years from now, there's actually incentives for people to store it? So it's kind of one of those interesting incentive holes in the industry, is that in general, blockchains just don't have incentives to store the data. You're actually incentivized to prune as much data as possible. Well, Arweave solves that by focusing on the data storage side, making sure that it's sustainable to pay for it. So the broad principle is that we want to build a new library of Alexandria, where there is no single centralized point of failure, such that this cannot happen, which is what everybody remembers the Library of Alexandria for. So one way or another, the problem with archiving is that at some point in time, your central location where the data is stored, whether that's books or scrolls back in thousands of years ago, there'll be a fire, a flood, or the government will come and they will try and burn it down. And one way or another, the data is gone. So obviously, blockchains are a kind of resilient way to replicate data around the world. And now if you scale it so you can fit arbitrary amounts of data inside, well, then you see how it all kind of fits together. But there are other reasons to store history inside a blockchain too. It's not just that the data is replicated across the world. And this is summed up pretty much in 2 quotes, I would say. The first, history is written by the victors, although there's some irony. Apparently, we think that this was said by Winston Churchill, but we don't know for sure, because nobody is storing the history properly. Or, as George Orwell put it, who controls the past controls the future, who controls the present controls the past. And this points to the really important part here, which is it's not just an academic exercise to remember history. We actually act in the future and in the present, dependent on how we believe things have happened in the past. So if you can change the way people believe things happened, or what was important from the past, you can change the way that they act in the future. And you see the authoritarian regimes all over the world, and throughout history, frankly, have done this. They go back and they start to edit the record, they start to add emphasis to different areas that weren't there in the contemporary time to change the way people conceive themselves and their culture and the world around them so that they change what they do in the future. This is no longer true. Anyone can write onto Arweave. It's totally permissionless and it's global. So it has these properties of making sure that the data is around forever through an endowment, making sure anyone can write to that ledger without having to ask permission, and then making sure that that ledger is not stored in any single centralized place, such that you can be confident that there is redundant data storage in, frankly, many different jurisdictions. So we started out 5 years ago trying to build this thing, when in the 2017-2018 era, there was a lot of hype around blockchains, but there wasn't really much on the ground that you could use other than, say, Bitcoin and raising money through ICOs on Ethereum. Since then, we've seen a huge amount of growth and some learnings, which I'd like to kind of pass on to the collective group here. And I think there are some opportunities that we can address together if we sort of act right. So the first time after launch that we saw this sort of collective ledger of history being useful, really, truly useful, was actually like 7 or 8 months later, when Russian, if I remember the incident correctly, Russian Navy boats essentially took hostage 14 or 24 Ukrainian sailors in the Kerch Strait, which is just on the south side of Ukraine. But when this happened, someone from our community, someone in our Discord server, managed to capture the first English language, frankly, propaganda piece put out by the Russian government through Sputnik, one of the international news outlets. And the interesting thing about it was that it was actually kind of pro-Ukrainian, but it was only online for 14 minutes. And fortunately, someone managed to capture it in that time, and then it got deleted on the centralized web. And when we found this months later, we realized, we can now prove that this was associated with what Sputnik was saying at the time, and that they've essentially now tried to memory hole that piece of history. But they can't. It's actually replicated in like thousands of places across the world in dozens of different jurisdictions. And one of the things we were interested about by this was that it got like some small amount of traction in mainstream press, which we really weren't expecting. And I find that very encouraging because it shows that there is some interest out there in the mainstream for other uses of blockchain outside finance. We just need to go and tell people about it. So then the next major event in the kind of history of this ledger happened in April, approximately 2019, when a group from our community started to archive documents related to the Hong Kong protests. And they were doing it live. And that archive became, I think, somewhere over 600,000 individual units or pieces of history at that point. So it's actually probably one of the best put together archives of that time in Hong Kong that is available. And it's now permanently publicly available to anyone across the globe. And then after this, and I think this is another interesting learning, Google told us that a state had tried to attack our Gmail accounts, which we thought was actually very interesting. We assume this is China, we don't know for sure, but they're the only people that might have an interest in this as far as we can tell. But it teaches us something useful, which is that states care about the people involved, more so than the infrastructure, still. Like we imagined if a state ever tried to attack Arweave, they would try to take down the infrastructure. They would try to find holes in the node implementations themselves, or something like that, or just try and DDoS machines. But it turns out that they see it in a more traditional fashion, which is the humans are the weakest link. And so I think that's something we should really kind of take to heart in the crypto ecosystem, frankly, that, as robust as our systems might be in a decentralized way, you, the humans that built them in the first place, are the point that the state will try to attack if they try to attack that system. So decentralize everything quickly, I think is the learning. Okay, so next, after this, there seemed to be like a on-the-ground community of Arweavers in Hong Kong that sort of started to naturally emerge, which is really, well, it's powerful, and to some extent it's pretty amazing to see. Like, we always hoped that this would happen, but it's amazing to see it happening in the real world, and also that frankly, the people involved in this are taking some risk to do so. So we're extremely thankful for that. But the next thing we know, I wake up one morning and there's a CNBC article about how Apple Daily, which was a sort of, you could say, pro-democracy newspaper in Hong Kong, had been archived onto Arweave just before it was deleted from the centralized web. And this, again, encouragingly got traction in the US Senate, where it was referenced as a non-financial use of blockchain. So there really are people out there that care about this. And it's my opinion that the thing that we could all work on together here is more loudly communicating that there are these opportunities to use blockchain for something that isn't speculation. And I fear that if we don't do this soon, the whole industry is going to be regulated as if it was a massive casino. And that is going to screw up all of the stuff we're working on in Web3. So I think there's a really, really important time-critical window for us all to come together and try to shout about these non-financial uses of blockchain that can be hosted on many different chains, but also in like chain-specific stuff like Fluence and this kind of thing. Okay, so then in this winter, we found again that people in Hong Kong have been archiving records, this time from Stand, which was the final remaining pro-democracy publication in Hong Kong, onto Arweave. Which is, again, it's pretty amazing to see that there really are users out there for this technology that don't have to be crypto aware. Like, I'm not of the opinion that people in Hong Kong using this are like die-hard crypto people. I think they're actually pretty, non-technical even potentially, but he's not that technical, which is encouraging. And just yesterday, we started to see a huge amount of traction in the Arweave ecosystem, storing records from the ongoing flare-up of tensions between Ukraine and Russia. And now the scale is much, much larger. They're storing almost 1 million pieces of history per day. So that's the story of Arweave. That's why we're excited about storing history inside a public ledger. I'd say that the key takeaways are that blockchains can be much more than just financial platforms. And we really have to tell the mainstream about this sooner rather than later. Like, we are at an inflection point. I'm sure you all saw what happened in Canada yesterday. Well, if we don't act quickly, I think that there's a high degree of likelihood that regulators around the world conclude that the only use for this technology that we're all collectively working on is in the financial realm, and even further, it's just unregulated speculation on assets, essentially. But that is not what we are as an ecosystem. So thank you for the time. I hope that some of those messages were interesting and useful. I'll pass it back. Oh, questions? Yeah, open for questions.
I think the use cases you mentioned are extremely admirable.
And if you could repeat the question too.
I don't really need it, so I'm curious about the opposite use cases, like where at least society will agree that there's, sexually predatory video, that material and that stuff. What kind of stances are we taking on that?
Yeah, I mean, the Arweave stance on that is pretty simple, actually. We just, sorry, so the question is around, if I can put it in 2 words, objectionable content, essentially. Yeah, exactly. So the Arweave stance on this is pretty simple. I think that we need to expose data to the rule of law. So on the internet at the moment, when you use a website, you want to say something, a company has to agree that you should be able to say it, and then it should be legal. It's kind of a 3-tier process. But with Arweave, what we're saying is actually, we can remove one of those tiers, because the company having the right to tell you what you can and cannot say is not actually how the world should work. It's just it happens to be that the web had no public spaces before the decentralized web came along. Each web address you go to is someone else's property, fundamentally. You're accessing someone else's server, which is literally owned by them, and you're there at the grace of their invite, which they have the right to remove at any time. Well, we can make a space on the internet that is actually governed by the rule of law. Miners in the Arweave network can see the data that they are storing, and they can analyze it and say, well, do I want to store this? Yes or no. They're incentivized to store everything, but that incentive for a single byte is relatively small. Right? And so the disincentive for storing something illegal is massive, because the law is there to stop people doing that. And so essentially what you get when you use the system is, cyberspace governed by the rule of law. And then if we, as members of a democratic society, want to change the laws to govern what we can say, then we have the means to do so. It's called voting. That, I suppose, is the stance. There's a couple more pieces to it, but I'll just leave it at that. Thanks. Anything else? Yeah.
We have a mic here. One second.
Okay, the mic is coming to you, apparently. Or not. Or, yes.
Thanks for the talk, Sam. That was great. I have a question about, so you mentioned the importance of like showing mainstream understandings, bringing to the mainstream attention applications of blockchain that are outside of, just financial services, or like, so to speak, the shovels for the gold rush. I was curious, do you have any shout outs for like other projects where there's like, I guess, intrinsic off-chain value being created that is enabled by blockchain?
That's a really interesting point. I think there's a lot of work in the area of what Lasse calls network states, and I think that's super exciting. Things like, what we see it as in the Arweave team is creating a state in a box. So if a blockchain is a trust computer, right, which is largely what it is, it allows you to do computation collectively without having to trust anyone, then one of the obvious uses for that is to replace parts of the state where we have had to previously delegate authority to a single centralized trusted third party, which we call the government. I think there's a ton of work going into stuff that, in the space relative to like NFTs or DeFi, looks kind of boring on the outside. That is actually really profound. And over a long enough period of time, we might be able to hope that we can replace trust in the state, in large part, with trust in decentralized computational technologies, which are being developed. So I think that's definitely one. I'm sure there are others, but that's the first that comes to mind.
I got a question, sir.
Hey.
About rent. So when you go get your standard contract at Metaplex, and you're going to deploy an NFT collection. And by the way, big fan. Your product, man, absolutely awesome.
Thanks.
So I've never advised the team to collect the rent back unless the project failed. Why is that code in the back end that says I can go collect the rent back? Like say I dropped a 5K degenerate commit collection, I paid the 5, 6K or whatever, in Solana to pay the rent. Why is that code there to get it back in the end?
I'm
sorry.
I'm not Solana, so I can't tell you that. So people use Arweave with Solana sometimes. They store the NFT data itself on Arweave, and then they refer to it in a contract on top of Solana. And so I think the rent recollection thing you're talking about, that doesn't exist in Arweave. Actually, once written, even the person that uploaded it can't take it back. And the reason for that is the rubber hose attack, right? You think your encryption is so good. Well, what about when someone comes along with a rubber hose and starts hitting you with it? Well, now your encryption is not so good if you know the password. So it's the same with Arweave. If you store a piece of data on the network, nobody should be able to come with a rubber hose and attack you, so you delete it. So yes, we don't delete state ever. It's just not part of the protocol. But in terms of Solana, I think the reason that they added that, and again, we've worked closely with Anatoly and the team, but I can't represent them, so take it with a pinch of salt. But I think what's happening there is they want to avoid state load over a long period of time. So if you have rent, then you get an incentive for people to come along and lower the state of the network, which, if you're running this thing for like decades, that makes sense, right? You don't want to have to collect dust with old NFT projects that no one's using if they never got sold. I totally agree, frankly, that this stuff should be immutable. Like when you buy an NFT, you obviously shouldn't have the potential danger that someone comes along and deletes it from you. That's crazy. And that's why it's so cool lots of projects are using Arweave for NFT storage. But I hope that answers the question somewhat. Okay, cool. Thank you so much, everyone. See you later.
Thank you, Sam. Next up, we have Evgeny from Fluence. And just to give you a sense, Bernard, do you want to stand up and give way? Because Bernard is also part of the Fluence Labs. And everyone here should give a hand of applause to Anna, who organized all this, but is at home with COVID, unfortunately, on TV. So thank you, Anna, for organizing all this and pulling all these things from afar. Evgeny is going to start kind of a little bit where Sam began as well, which is kind of the importance of Web3. And I think all the projects here are going to go into the real driving forces as to why Web3 is important. And each one of the projects here is going to talk about their implementation and the problems that it solves and why it actually makes the world a better place and a more functional one for all of us. And Evgeny is going to be discussing a lot of the similar things, at least initially, that Sam did, less about the storage of data in perpetuity, but more about the importance of centralized systems and how things can be censored. And Sam has one approach, which is the immutability of data and actually keeping it alive forever. And what Fluence helps do is create systems that do not have centralized parties and do not have centralization, and also are more resilient than the current centralized systems we have. So it's another way to attack kind of the same problem of the flaws in the existing kind of infrastructure that we all are bound to more or less today.
Okay,
And
now I see it.
we are now up.
See it now? Yep.
So Evgeny, give it to you.
Hey, hello everyone. Actually, Anna, our team member who organized all this, said there is unlimited drinks somewhere here, I guess. So if anyone wants to, like, there's a food and some drinks, so feel free to get it. So I'm gonna talk about Fluence. This is basically the evolution of compute roughly. Right, so we are now at the cloud computing stage, and we are sort of entering the big peer-to-peer era of the computation platforms. And the state of computation platforms in terms of decentralization is now that we are perfectly decentralizing a financial system.
We're just gonna switch mics real quick. This one's a little bit better.
Okay. Oh. This one is better. Yeah, so we have solutions for storage, identity, sort of networking, but what about computing? And this is what about computing. Right. So smart contracts work on-chain, works for financial use cases. The problem with them, they by design are redundant, deterministic, constrained, and expensive. And there was an attempt a couple of years ago with sort of creating hardware, like a compute resources marketplaces that were intended to make possible high-intensive computations in a decentralized network. But they also have, this is basically limitations. And ideally, what we want to have in terms of computing is to have something that would really be able to replace Amazon services, like cloud services, to host the traditional applications backend, mobile applications backend. So we need something that would not have, big gas for usage. Like I don't want to, as a user, I don't want to use the new Web3 decentralized messaging application and pay gas for every transaction. And there should be something that, universal enough and as cool as content addressable storage, and content addressable storage is cool as we know it. And it should be pluggable to whatever exists already in terms of other tools like storage, like Arweave or IPFS, identity systems, blockchains, and things like that. And we kind of envision that this is what should be built, and this is what we are building at Fluence. And basically the demand comes from two things: the anti-centralization movement in in Web2 space that is really topical right now with all of, big hacks of Facebook and things that happen in the world, like Sam mentioned. And also like Web3 specific use cases, like cross-chain use cases, off-chain, like things like chain governance for where people don't want to pay gas for every vote that they do in the DAOs, for example. Like interoperability between applications, between chains, between systems. So it's all very important. It all requires some off-chain layer that enables general purpose compute. And yeah, again, like all of this probably pretty obvious. Amazon and like traditional cloud systems are not as reliable as we want them to be. And one of the biggest things is that they can deplatform not only users, but they can deplatform developers as well. Like if they create SDKs and if they create developer platforms, and then you kind of trying to build the business on top of their SDK, on top of their API, they can cut you off at any moment. And that happened already many times, and that's really bad. This is what really prevents from innovation on the Web 2 on this like API integration level. And this is what kind of solved in the blockchain space for DeFi for smart contracts, because if smart contracts is deployed on chain, then other smart contracts can use it forever if the ownership rights defined properly. But like conceptually, you can use other smart contracts from the chain forever because they designed it in this way, so they cannot be changed. And we need something like that for more general compute as well. And in Web3 also there is elephant in the space. There are big ecosystems that like totally Web2 style have like complete locking of their users of their ecosystems. And there is other a lot of solutions, a lot of projects that build in great things, that build in on top of on-chain data or decentralized data. But basically the products that they have, if they want to build some API, they want to build their product currently and provide decent user experience, decent performance for users that can consume it from the devices, from the browsers. The only kind of technology that they have today is all the same centralized cloud technology. So that's why we have a lot of great projects doing centralized developer APIs, and a lot of DeFi projects and on-chain projects rely on centralized backends. So basically they proxy all the users through their centralized backends, and it's the same issue of locking as we have in Web 2. So peer-to-peer proposes better approach, which is somewhere in the middle between centralized computing and blockchains. So if you have this like a peer-to-peer system that allows to run applications, we can avoid too much redundancy that comes from blockchain, and we can still have the code running verifiable or like optionally verifiable. It could be secured with external chains, but it will not have any central middleman. We will be able to run it as on a network and not on some centralized thing. And if we have it, then basically we can transition all the centralized APIs or applications into peer-to-peer protocols. So basically everything becomes protocol, but not all protocols live on-chain. Some protocols start living off-chain, which is very cool. And this is basically what we built at Fluence. And Fluence is roughly 3 parts. There is a programming language that allows to create peer-to-peer protocols very easily and abstract out a lot of complexity. There is a network that runs this programming language, and there is economics around all of this. Just shortly in Aqua, it's basically the language that you use to express distributed coordination, or like express distributed business logic in terms of nodes and peers in the network. And it works differently from how client-server model works. Like usually when you create your centralized applications, you either have a central API or you have a client that calls back and forth several services. And you always have this piece, the controller piece that talks to all the other involved remote servers or services or APIs. And Aqua allows you to program the flow, the execution flow across remote services, remote APIs, remote peers. So you have the piece of code that basically travels over the network and triggers the execution of different services. And it's very simple. So like in terms of programming, just like a few lines of code. And based on process calculus, and basically allows to, when you create this code, this becomes the protocol basically on the network. And the idea is this language becomes the there are a lot of primitives, distributed primitives that comes with the language and can be created with this language that allow you to create more and more complex systems. Like currently there is a ability to discover peers, to connect peers, to discover resources over the network, to understand whichever peers are in different groups, which serve this application or that application. There is a connection to file management, and it's IPFS, there will be Arweave as well. There is connection to data streams from Radicle, to Ethereum and mirror chains, and there is also like a primitive of trust graph, which allows to build the sort of semi-trusted compute systems where you can deploy your application on peers that you trust directly or transitively via other known parties. And there will be a lot of things like replication consensus, notification, like things that you used to have in the cloud, components that you will be able to use to create your app at the same level, like to think of designing your app at the same level as you think when you're using cloud services. There is a network that runs all this language, and basically the network, all the peers in the network are different. So it's not like blockchain where all the nodes have the same replicated state and there is a global consensus and they verify all the incoming transactions. Here, every node is different. Every node decides what to host, which applications to host, in which protocol to participate. So this is sort of like the big marketplace of protocols. And some of the nodes provide connections to external things like Ethereum or IPFS or Arweave. Some just run pure Fluence native computations. But that's basically the peer-to-peer marketplace where you can discover available resources and deploy your stuff. And just a little bit about composability and lock-ins again. So in blockchain, like before blockchain, all the systems that we have in the cloud, they were very focused on the author of the owner of the application. So I'm a developer. I create the application, then I deploy it to my server, then I pay Amazon to my server to use my credit card, and then users use my application accessing my server. So the problem is I'm controlling everything. So I can cut off like them at any moment. Amazon can cut me off at any moment. So it's very vulnerable. In a blockchain, you basically have the separation between servers and authors of code. When you build smart contracts and deploy to the network, now you're not really controlling if this code will be running there tomorrow, because it's now miners, like or node providers, validators, they are responsible for it. So we are trying to enable the same model, but for not for blockchains, not bringing the global consensus here, but for like a general application space. So there could be different node providers that can decide whatever applications they want to serve. And even if author wants to update the app, but the node providers don't agree with this update. Maybe this update is unfair, or this update breaks something, or if this update, cuts off some integration. The node providers, the network can decide, some part of the network can decide to update, and some part can decide not to update. So users will basically follow whatever version they want to follow. So it could be like really successful updates or not successful updates, so like the forks of the applications, basically. but this allows to solve the deplatforming problem. This allows to solve the access cutoff problem. And this also, because we separate this runtime from the authorship, we can really create a system where we have the same composability level as on blockchain. So you basically can deploy primitives into network, and then you can safely build on top of these primitives more complex applications and more complex business logic. And like you can, like for DeFi, this is now how it works right now. Like you basically have the stable coins. From stable coins, you have more and more like you have DEXs, you have AMMs, and all of them like building on top of each other. Now we can have similar things for the for any application. So we can basically create more complex protocols from basic protocols, and then you can package them as different applications. So combining two of these, we can have WhatsApp. Combining other of them, we can have Instagram. Yeah, so this is pretty cool. And the last thing is the economics of all this, how it all works. There's like a huge space of innovation here because at least applications or protocols deployed in the network can be managed on chain with DAOs, which is pretty cool. You don't need to you don't need to pay with credit card. You don't need to have a single admin who pays for making this protocol for making this protocol available tomorrow. So the DAO can make these decisions. The DAO can pay nodes for providing the application. There could be a very cool thing that because the network becomes sort of the new cloud, and there is the revenue coming from application developers to node providers, and this revenue gonna be on chain because like that's the only way to organize payment system in a decentralized way. This revenue also will be very transparent, so it will be possible to track whatever software piece generated whatever amount of revenue. And basically, if I'm creating something useful, some useful piece of application like a database that can be usable across applications in Fluence, and I create an open source, right? I deploy it and give it to people. People use it to create applications. These applications generate revenue for the nodes that provide these applications. And then I'm as author, I can earn some royalties, some part of this revenue, so like a small piece of revenue of the cloud. And this becomes the new way to monetize open source, which is not possible currently in the cloud because Amazon will never share anything with you, even if they earn billions of dollars providing popular database as a services. And also there could be like another layer of innovation related to how do you pay for the compute on the network? Different types of contracts for compute, different types of offerings, different pricing for different computation verification models, and things like that. And this is where we are. So the network, the off-chain network, and the are live and running already. We now we're very close to launching the DAO and the governance system for the whole network, and we plan to roll out the economic pieces, one by one. Something coming this year. A lot of things probably will come in the next year, but this is where we are. You can check out the network dashboard. There are services, nodes, things like that. And yeah, so thank you. That's it. Yeah, questions?
Test. So as we move into a decentralized, permissionless, trustless compute world, how do we trust the underlying hardware? What comes to mind is Huawei, right? US Captain said, all right, the US cannot use Huawei hardware in the 5G network because we can't trust that piece of hardware. Are we going to be faced in this future where we can't trust underlying compute hardware because it's supplied by, a central authority we don't trust.
Yeah, so I guess the core benefit of using decentralized technology versus cloud is that you build on the open source stack, and you build on the stack that allows you to very easily switch between nodes if you need it, like if you really want it. And also, by default, Fluence do not enforce any computation purification model just as a default, but it allows you to choose in terms of your application. If you want to deploy to some random nodes, and probably you don't trust these nodes and you don't know which hardware they are. Like there could be different hardware, it could be the same hardware, it could be like all the same provider, it could be different providers. But you can require them to have consensus. Like if you want, you can like consensus to part of your computation. But in many cases, you just don't need. Like in many cases, what you can do is you may have the you may apply the trusted sort of like a semi-trusted setup for your computation. You may say, okay, I know this authority, and this authority trusts this and this and these providers of the computation. So when I deploy my application in the network, I would find if they run it. But however, like all others, I will not allow them to run because like I don't trust them. Or if I don't trust, if I want to deploy on nodes that I don't trust, I probably would want them to have consensus. Maybe not, maybe yes, maybe I will but I'm not limited to it. And I may also have, we might have also, it's still kind of in the future, but like ZK proofs, things like that. But all of these things work on only very specific types of computations. So the idea is we will, we together with the ecosystem, we will figure out what makes sense, what verification models make sense for which use cases, and they will be available as the options for you when you build stuff in Fluence. So I hope this answers.
Great, thanks, Evgeny. Also, just to know, if we're interested in learning more about Fluence, 2 p.m. tomorrow is the developer workshop within your co-working space, so right around here. So that's if you're ready to get deeper into the code and how it works. Up next, we have from Protocol Labs. So we had to separate Protocol and Arweave by Fluence. And so he'll be up in a second. We're actually very happy at Fluence to be supported by both Arweave and Protocol Labs. And I think that gives us the storage that those two protocols offer are the perfect complement to the compute that Evgeny was talking about. When you think about creating a decentralized AWS, you need payments, which blockchain takes care of. You need storage,
give a slide to it.
which is what Arweave and IPFS, Filecoin, storage, and
So
others
this
create.
goes to that
And you
screen
need
up there.
decentralized compute, and that's what Evgeny explained in detail about how Fluence adds that. But you need those three things to work together. We're going to have a decentralized, truly decentralized Web3 experience.
So this mic is for the,
So,
this goes to the live.
oh, and so after, and this is a pressure on Vuk, because after Vuk, we have break. So Vuk's between you and the break,
This is for
and
the
then
live
it's
stream,
followed
and
by
that's for
a
the
panel
audience.
that will have both Arweave as well as Fluence, but also Livepeer and Radicle, moderated by Lasse from 1KX. So that comes directly after the break, which comes after Vuk. Here you go.
Thanks. I'm gonna talk today about what do we actually mean by Web3 and the path that we see actually getting to really something that we can call Web3. Jim, is the mic okay or? Okay. Yeah, I was highly advised to have last slides, but I did not follow that advice, so we have a bunch to cover. So I've been part of a few ecosystems. One was the German ecosystems in 2017-18. Then I made the decision to go into the Cardano ecosystem, since I like doing strange things. and then I moved to storage because I think that's like the missing piece to actually get to a world where we actually really have Web3. Yeah, so yeah, this is killing me, like those speakers, I need to move away. Yeah, so basically we have a couple of problems that we're trying to fix with Web3. So first of all, we have like no way of controlling our data. Like even if we do anything like in today's world, everything is being managed by a legal entity that is headquartered somewhere, and the government has like full ownership over that data in that particular case. Now, there is also very little clarity what's being happening with that data, because like if the US wants to get some data about me and then being in Serbia, for example, the US can easily do that because I'm probably using a service that is built by a company that is headquartered somewhere in the US. And of course, there is no transparency on how like I'm getting like the content from those services. So I'm going to see some particular feed, and that feed is going to be there because like Facebook thinks that I'm going to be clicking more those particular things, and they will be generating more revenue because of that. And all those abstractions are being built by those companies that are actually there just for one single reason, which is pretty obvious, and that's to generate profits, and that's why we have markets and why those companies have shares and they do stuff for their shareholders. This is something that we definitely want to change, and this is something that we're doing with Web3. Now, there are a few things that are happening that are kind of tackling some of those issues, and those are by using the tools that were available for the last 100 years, and that's of course regulation. We're trying to do a few things in Europe with the GDPR. Of course, the Congress is doing a bunch of things trying to actually get to a place where tech companies are not actually doing that, but those are things that are actually semi-solutions. Those are not really solutions because you have like a bunch of lobbying that is happening, and if those companies have so much power, they're also able to have influence over that lobby, and we really have little influence over what's actually happening with our data. The real issue here is the infrastructure. In fact, even though like the European Union had like a bunch of requests from Facebook in Europe, but they were not actually able to fulfill those. Why? Because Facebook can tell you, okay, fine, you're right, we're doing evil things and we're evil. The only thing that we can do is shut down like the infrastructure that we have, because we have no clue how to build a better one. And if you're like a decision maker in a government in Europe, if someone tells you that they're going to shut down Facebook, it's hard for you to say okay. So we need to slowly move to something else that actually allows us to manage that infrastructure well. And this is not by chasing away Facebook, this is by defining the kind of abstraction that we want to have in the next world that we are building today. And the issue is also that most of the tooling that we have today is basically built on top of those tools that were built by those companies. So even if you are not aware about what's happening there, and you're using something like Firebase, by default you're going to obey to all the rules that are defined by those cloud providers, and by default you're going to give all the ownership over your data to something like the government of the United States, even though like you never agreed on that. So yes, yeah, those are the things that we are basically changing. So from a world where we are like referencing data, like the location of the data, we want to get to where we are referencing just the content, and we're doing that by using the CIDs. Also, we don't want to be in a spot where the data is basically owned by a particular company that is paying the bill of the cloud in that particular moment, which is the situation right now. Instead, we want to have like companies that are participating in the ecosystem and building products together. And of course, we don't want to have like infrastructure that is owned by legal entities. Instead, we want to have common infrastructure that is shared between like the users, the developers, and so on. And that shared like incentive models between them. Where we are today, so we have like a couple of things already. So IPFS is a massively scalable retrieval network, which allows us to actually get the files that we are storing through those CIDs. We can of course like archive those, and in fact, Filecoin today has more than 16 exabytes of data stored, and that capacity can be used by developers for almost free. And of course, we have bridges with the blockchain that allows us to tap into like payment systems and have like a way to store those CIDs in smart contracts and so on. Then we have networks that are actually supplementing the main network, which is Filecoin, which are kind of helping us put the abstractions between the retrieval and the archival. In this case, like Estuary, what it's doing is it's allowing you to just pin a file, and it would take care of the storage orchestration on Filecoin. So the only thing that you carry is the CID that you want to store on IPFS, and the rest is going to be managed by Estuary for you. Of course, you can run your Estuary node as well, and Estuary at some point is going to become a network that is independent from Filecoin. Dexter is doing something similar. They will have like a trusted bridge at some point. Right now, it's a bridge that is being managed by them. So basically, they are storing stuff on Filecoin, and they are just injecting particular information in smart contracts on Ethereum. Now, I want to cover quickly where we are in terms of how this is going to be run in a particular data center, because I feel that very few people are actually talking about that. We have compute networks, we have storage networks, but how are those talking together? If I'm doing some compute on Livepeer, for example, I need to encode something, am I retrieving that from S3, and then I'm doing the compute on Livepeer, and then storing again on S3 or pinning that? Those are things that we need to define yet, and those are basically the things that I want to cover today. So you can imagine Livepeer being like the compute network here, and basically our workload is going to come to the Livepeer network. For example, you want to encode a very big video, and you want to encode that in different versions. What you're going to do is you're going to get some source information. Ideally, that would not be coming from S3. That would be coming from a file that is stored locally on that network. And then you're going to do some computing, and then you're going to store that somewhere. That somewhere needs both to be storage, like Filecoin, but it also needs to be a retrieval network like IPFS. Because at the end of the day, that file is going to be retrieved by the user that needs to see that video on his mobile or whatever else device that he's using. Now, it's very easy to say, fine, the Livepeer node is going to write somehow to Filecoin, and then it's going to be pinning it and so on. Actually, that's not what's likely going to happen. Instead, we're going to have a retrieval there that is also doing the caching between Filecoin and IPFS, because you as a developer care only about reading that from IPFS and writing that to IPFS. Everything else needs to be managed for you. And in a way, you could see a Filecoin as a hard drive that is very big, and you have the sectors on that hard drive. I'm talking about not SSDs, traditional hard drives. You have the sectors on the hard drive, and you have ways of reading those sectors, but you also want to have a file system on top of those sectors, because someone needs to be managing that. And in the case of Estuary, you could think about Estuary as being that file system that is doing the caching. He understands where the data is cached. For example, on the hard drive, the data most likely is going to be cached on the DDR memory that is actually there. So it's not going to read that from Filecoin. And the same thing is happening here. You're not managing that logic. That logic is being managed by Estuary for you. The greatest thing of all is that content is never moving outside of the data center. It's always inside the same local network, so you could be transferring terabytes of data with 20 times faster speeds. Because if you're going to the internet, the max that you can get is probably 10 gigabytes. But now with the more advanced networking stacks like Mellanox with 100 gigs local networks, you can actually move data much quicker, and all of that is happening globally. So instead of wasting 10 hours to retrieve data to your compute cluster, you're just going to retrieve that from some local node that is sitting in the same data center. Even better, if you're using a colocation like Equinix, you're going to most likely leverage the private fiber that Equinix has instead of going outside to the internet and going to Google and so on. Now, at the end, what's going to happen is that the end user is just going to retrieve that file or the result of that compute through IPFS, which is going to be routed from the closest node to that particular user. Why we are doing all of that, and what are the benefits that we're going to get? First of all, we want to really make it Web3, and whenever someone says Web3, it means like the user is going to be only whatever you're doing. Either it's a smart contract or NFT, the user needs to own that. And that the same is for Falcon and BFS and any other network. Like we need to allow users to actually own their data. And for that, we'll need to do some cryptography on the client, and the client will need to manage that somehow. But the user needs to own the data. Right now, we're just working on the infrastructure that is going to allow that, and that's why we push so much CADs, because that's the only way of not routing data from locations, rather routing data because of the content of the data. And if you want to encrypt that, you really want to get the CAD. You don't want to get the location. Also, the internet is kind of busy today, and bandwidth is very expensive on the public internet. So what we're doing with this is we're offloading that particular infrastructure with files that are actually being stored on the same data center, and you as a user being able to actually batch jobs much quicker without having to retrieve massive amounts of data to your computer. And something that Falcon did for storage that we are also trying to work towards with partners is get to a point where computing is commodized. Miners that have GPUs that are farming Ethereum right now should not have those GPUs either. Those GPUs should be computing probably some cancer research data or trying to figure out things that are going to help us solve much more complex problems. And finally, because of the economy that we have created with Falcon, we think we can get to a model where users are actually owning their data and getting rewards for actually generating the data, which is the default case that we had to have since the beginning, but somehow for the past 40 years, we went in a completely different direction where companies are actually monetizing our data. We are very aware of that, and everyone is okay with that. So yeah, I would like to wrap up there, and happy to answer any questions. Cool. Thanks.
All right, we got a 10-minute break now. Everyone gets a reward and then we're going to get back to the panel. So we're going to set up a panel right now. So grab a drink, grab a snack, use the restroom, we'll be back with the panel shortly. Thanks.
Yeah. No, I'm not used to being in front of four speakers. Oh,
Yeah. Yeah, and I think this thing just should pick it up. Yeah, that's probably
All right, I'll get Ben and we'll set the time.
I see you here, yeah. Scott, yeah, and you are.
Okay,
Once a year
so
doesn't-
what do you want to do with the table?
I might just get rid of it, but I want to keep.
Turn it on its side over there
Yeah.
somewhere.
I don't have a long. I'm on a short leash here with the
Okay,
camera, so.
let me know. We're going to do 6 chairs.
Let me take this.
Yes, I think so.
What's happening?
What type do you want on this table?
Huh?
What do you want on this table?
Well, maybe we'll do this mic. Shoot, I'm gonna have to get crazy with it.
I might have a smaller table if a little cocktail table would be easier for
This
you.
is fine. This is fine. It's just.
Need something to lift it up so it's not wobbly?
Yeah, once I get it straightened, I think it'll be all right. Oh shoot, what's going on here? What's this? Oh yeah, we should be all right.
You know, you can put the table behind them.
I can. Well, the problem is I'm on these leashes. This is my internet here. That. This mic. These little short ass cables here.